Hey everybody, my name is Jason, also known as Pirate JC, and welcome to another Babylon video. This is part 6 of our epic video series entitled A Tech Artist's Journey, where we are going on a crazy adventure together, a curvy, twisty adventure like a hike through the woods to create this dancing morph target demo. If this is your first video with this particular series, then you'll want to know that it's not about taking the most direct path to getting to that demo. No, this series is about doing the opposite. It's about getting into the mindset of a tech artist and taking the road less traveled, to see something we've never seen before, to try something we've never tried before, to learn something new. It is my sincere hope, if you're following along with this series, that that is what's happening, that you're learning something new. In our last video, we left the world of Blender behind and moved into Babylon, where we started to build out our scene. We've created an array of all of our morph targets that we're later going to animate. And in this video, the magic begins. This is where we enter the state of a tech artist, where we start to really have to wrestle with some crazy concepts. I am so excited to share with you that in this video, we are going to take the animation data. Remember, we started with a fluid simulation and we captured images of that and stored it into a texture. And then we're now going to take that texture and rip that data right back out again to use as animation keys in Babylon. How cool is that? All right, without any further ado, let's pick up right where we left off in our last video. If you're following right along with the whole series, make sure to save your work along the way after each video. You can do that by simply clicking save in the playground. And let's go ahead and get started. We'll start by removing this console log from the last video. And what we're going to do is we're just going to get started right away. We are going to create a new function that's going to strip the data out of the texture and hand it back to us as ready to use animation keys. It's all going to be done in just two simple functions, but we're going to create the first one to create the keys for us, okay? So we'll start by saying this: let animation keys equal await, because we're going to create a new asynchronous function, and we're going to call this get animation keys from texture. Now that's going to take in a specific texture. The texture, of course, that we're looking for is the one where we stored the data in it, but how do we get to it? Let me actually show you something. I'm going to comment this out for 1 second. Now think about back to when we started in Blender. We created a mesh. We attached a material to that mesh that was a principal BSDF shader, and then we attached an image input as a texture into that shader. And that texture, of course, was where we captured the highest point at any given frame of our animation. So it goes mesh, then material, and then of course the texture. And we can actually visualize this way. We'll start by clicking on the bars, and then we'll go to link to the material that the bars is using, that mesh. And then if you keep going down, you'll see that it has a albedo texture of the exact texture that we're looking for. So to show this to you, we're going to go like this: console.log, and we're going to log bars.material. And then we have a helper function here that is get textures. I think it's get active textures. Oh, of course, I have to hit dot. That would be helpful. Get active textures. And that, of course, is a helper method. It's a function. So if I hit play right now and we go back to our console, you can see that I have an array, and it has returned an array with one object in it. And that, of course, is the one single active texture associated with that material that is associated with that mesh. So if we go back here and we change it by saying I only want the first instance of the get all active textures, it will of course then give us the simple texture. And so that is what we want to then pass into this new function that we're going to create. So we can take this bars.material.getActiveTextures and we can copy that and put it in here because that's the texture that we're going to pass through. I'm going to get rid of this console.log and I'm going to uncomment that line. And we're essentially now ready to start setting up our function. So let's go to the bottom. We'll create a new function. It, of course, is called getAnimationKeysFromTexture, and it's going to be an async function. And it is going to take in texture. Okay, that's the texture that we've passed it. Okay, now what we're going to do is we're going to create two different arrays. The first one we're going to call animation data, and that's going to be an empty array for right now. This array is going to be the thing that we actually store the data that we pull out of the pixels, okay? And then we need to do a second step to convert that into animation keys, because in Babylon, animation keys have a specific format. So we'll create a second array called animation keys, and that, of course, for now will just be an empty array. So the magic begins here, folks. The entering the mind of the tech artist begins with one simple line of code, and that is that we're going to let pixel data equal, and this is going to, we're going to wait for this to finish, texture dot read pixels, okay? And that is the function right there. Now, when we do this, if we console log the result of this, you're going to see something incredible in my mind. We'll hit play, we'll go back to our, look at that! In our console, we wrote out an array that was returned to us. So we have this awesome function that will take a texture, go through every single pixel, and return the numerical data associated with those pixels. How cool is that? Now we begin the transformation of this data into Babylon key data. Folks, this is incredible stuff right here, okay? Now, if you're looking at this and you're saying, something's wrong here, we only have 30-ish frames of animation, but I'm seeing 124 entries or items in this array, you'd be right. That's because our next step is we need to pull out every fourth value from this array. And here's why. If you look closely at what's happening, you'll see that we have a pattern. 3 numbers that match, and then 255. 3 numbers that match, and then 255. What happens with that read pixel function is it's going to return 4 values for every single pixel. The R, G, B, and A values, or the red, green, blue, and alpha values of any given pixel. So in this case, our first pixel has a red, green, and blue value of 0, and then an alpha value of 255. Now, for our purposes, we really only need one single number for any given frame. And because the red, green, and blue values are all the same value, we can just pull one of them. So we'll just pull the red value. And then we're going to take every single red value and store that into our animation data array. So here's how we're going to go about doing that. We are going to create a new loop, okay, a for loop. And it is going to have a fun iterative part to this, okay? Something that I find kind of interesting. We're going to say let I equal 0. And we're going to say while I is less than pixel data dot length. And here's where this is kind of interesting. We're going to say I plus equals after every loop plus equals 4, okay? So each time through the loop, we want to add 4 to I. Because going back to our array here, we want to take the first one, which is 0, and then we want to add 4. 1, 2, 3, 4, and take the fourth one, in this context, I guess it's the fifth one, and that will be the red value of the next pixel. And then again, when we go forward 4 more, that's the red value of the third pixel, so forth and so on. And so in this loop, as we go through this loop, we can say that we want animation data dot push, and we want to take pixel data, and we want, of course, to put the current time through the loop as the instance we pull out of that array. And then, of course, I'm going to console log animation data instead of the pixel data. And watch this. Now when we go back, boom, there it is, folks. Step 1 of our conversion, of our transformation from pixel information, color information into usable animation data. We now have our array with 31 different numbers in it, and that will be our animation of 31 different frames. And this is so incredibly amazing. It's now essentially starting to be set up. But if you're looking at this and you're thinking something is still wrong, if you have alarm bells going off in your head, you'd be right. Because we do have a problem. You see, this is using color information, which has a range of 0 to 255. Our array here of animation goes from 0 all the way up to 255 and then all the way back down to 0 again as that spire comes up and back down. But the problem is we don't want a range of 0 to 255. Check this out. We're going to go look at the bars here and look at the morph targets here in the inspector. And this right here, this box, this property is called influence. And that is the specific property that we are going to be animating. And this goes from 0 to 1. So we have a problem. Our array of data goes from 0 to 255 currently, and we need to convert it to go from 0 to 1. Now, you're probably thinking to yourself, okay, so just divide by 255. Well, let's go through this and try this out. We'll divide by 255 and see the result. We'll go back to our array, and you're right, that technically did work. We now go from 0 all the way up to 1, and then all the way back down to 0. But look closely at what we've just done. Look at how complicated the numbers are, at how much precision value we would be asking the CPU to compute on our behalf. Now think about this. This is just one animation going through all of that precision value, but we've got multiple of these things animating at once. So we'd be asking the CPU to do a lot of really, truly unnecessary work. So we could probably round that down a little bit. And that's exactly what we're going to do. We're going to start by encapsulating this in parentheses, and we're going to multiply it by 1,000, okay? So let's take a look at the result of this. We'll hit play, we'll go back to and now we have a range that goes from 0 all the way up to 1,000 and then back down to 0. And at this point, we can probably round to the nearest integer, right? That would probably be pretty appropriate. And that's exactly what we're going to do. So we're going to encapsulate all of that one more time in parentheses. And then we're going to say math dot round and hit play. And now what we'll see is that indeed we've rounded that to the nearest whole integer, which is great, but our range still goes from 0 to 1,000. And of course, we want it to go from 0 to 1. So what do we need to do now that we've rounded? We need to, once again, divide by 1,000. We'll hit play and go back, and there it is, folks. Now we have it. We have the data sorted and manipulated and morphed into the way that we need it to successfully animate the influence of a morph target over 31 frames to go up to 1 and then back down to 0. This is so cool! But we're not quite done yet. Remember, I told you that animation keys need a specific structure in Babylon, and that's what we need to do now. We have our animation data appropriately set up into an array and appropriately morphed and mashed into the way that we want it. Now what we want to do is we want to create another for loop. This one's going to be a for each loop. So we're going to say for each in animation data. Okay, we're going to loop through animation data here. And then what we're going to do is we're going to say we want animation keys dot push. And we're going to push an object, okay, a JavaScript object, and that is going to be in curly braces, and it's going to look like this, frame colon, and we need the frame number. Now, we can grab that by using each, but we need to make sure that each is set to be an integer because it needs an integer as a frame number, Babylon does. And so what we're going to do is we're going to say parse int. That's a handy little function that we can use. And then we'll put each inside of that. Then we're going to use a comma, space, and now it's value, colon, and now we need the value associated with that particular frame number. And so now what we're going to go do is we're going to say we want animation data, And of course, we want that to be each. Now, if I go and I say I want to console.log animation keys and I hit play and go back to the console, look at that. It is now set up for Babylon. How cool is that? We did it. We took animation in Blender, a fluid simulation in Blender. We animated it up, we put a camera on top of it, gave it a shader to pass it into grayscale mode, and then we used compositing to find the highest pixel value at any given frame and store that into a texture. We assigned that texture to a material on our mesh and exported it out of Blender. And we've brought it into Babylon, where we've taken the pixel data, we've read it, we've morphed it and mashed it and molded it into something that we can use to animate the influence of our morph targets. And now we've put it into the proper format for animation keys. How cool is that? This is the mind of a tech artist, folks, right here. It's morphing and mashing and putting things together that you didn't think could go together in this way. That's the point of this series. It's so incredibly cool. But we're not done just yet. We're going to do another thing. We're going to take these animation keys and we're actually going to go through the process of creating an actual animation. And that animation is what we will use to then play on top of the influence value of the morph targets. Okay, so we have the keys. Now we need to put them into an animation. This is the last step before they'll be ready to use. Okay, so of course this array or this function right here, this custom function, we have to return something, right? We actually have to return the animation keys. So now it's returning the animation keys, and just to confirm that we've done that right, we will console log that one more time. Again, this is me just being very visual. I like to see the result of my code and what I'm doing. And sure enough, we've got the exact same thing being passed back into our create scene function, our main loop here. That's awesome. Okay, so now what we're going to do is we're going to basically take those animation keys and we're going to put them into an animation. We're going to create an animation, and then we're going to use those keys as the key values and key numbers for that particular animation. So here's how we're going to do this. We're going to say let animations equal, and we're going to create a new function here, okay? And we're going to say get animations. Let's see, what should we call this thing? How about we call it build animations. There we go. That's something that we can easily remember. Okay, and then it's going to take in animation keys. All right, so this is now set up and ready for us to go, but of course we have to go create the, I'm going to get rid of this console log here for a second. We have to go create that function. So we'll go to the bottom of our playground here, and we're going to create a new function. Okay, so that's going to say let build animations, okay, and it is going to equal an async function. And that is going to take in something called animation keys. Okay, now I'm going to put a few lines of code under here just so that you can see this nice and easy. This is essentially now what we're going to do. We need an array, okay? So we're going to say let animations equal an empty array. Now, here's the point of this function. We're going to take in keys, we're going to build an animation, we're going to take that animation, put it into an array, and then return that array. You might be asking yourself, why the array? Can't we just take the keys, create the animation, and then use that? And actually, this is something that if we don't do it now will bite us later. The specific method that we're going to use to actually create an animation, to run an animation, it's scene.begin direct animation. It requires an array of animations to run. So we're doing ourselves a favor now and packaging an animation into an array. That's why we're actually doing it here at this point, save ourselves some trouble later, okay? So here's what we're going to go do. We're going to now create, we're going to say let pop up animation equal new Babylon.animation. And we are going to see what this wants as arguments in. It wants first a name for this animation. So we'll call this pop-up. And then it wants, now look at this, it wants a target property. This is the property that you're going to apply the animation to. And notice that it's asking for a string. So in this case, we want the influence. That is the influence of the morph target that is owned by the morph target manager that is then associated with a mesh. So the hierarchy here is mesh.morphTargetManager.morphTarget, and then of course the influence is the property that we're going to be animating. Don't worry too much about that. That's just something that you can know about the structure of how this will all play out later. Okay, so now what it wants is frames per second. We're going to say we want this to play at 30 frames per second, and it wants the data type. What is the type of data that we're going to be animating? In this case, it's Babylon.animation, and we're going to do a float. Animation type float. And then it wants loop mode. Do you want it to loop or not? We do not want it to loop. So we're going to say Babylon.animation, and then we can go up to constant. Animation loop mode constant. And that is now ready to go. The animation is set up, but of course we need to apply the keys to the animation. That's really easy. We just say pop-up animation.setKeys. And of course, the keys that we want to set are, you guessed it, the animation keys that we passed in. And then what we want to do is we want to say animations.push, and we're going to push in the pop-up animation. And so now we're taking that empty array, taking the animation that we created, we applied the keys to that animation, put that animation in the animations array, and then of course we're going to return it. Return animations. And now, if we go all the way back up here, we have animations equals, and we're going to wait for that to finish. But now if I console.log, check this out, the animations array that we return, we're going to go forward and look at our console and look at that. We have one single animation, we have an array with one single animation in it called pop-up that's going to target the influence of whatever we apply it to. And then if we open this up, check this out, look at the keys, there it is. That's our animation data inside of the animation keys format, wrapped inside of an animation. Folks, this is so incredibly cool. I hope you are as excited about this as I am. This is the mind of a tech artist. It's living in the world between art and technology and making connections that didn't exist before in our minds, to try new things, to try out new things, to see new things, to learn all kinds of crazy things together. It is my sincere hope that you are learning something from this video series, and really, I cannot thank you enough for coming along on this journey with me. If you haven't already done so, I'd ask you to please consider subscribing to this channel so that you don't miss any of the future updates that we bring. And again, thank you so much, and we'll see you in the next one.